Alright, good day guys, how are you all doing? We're talking about our continuation of another system of linear equation, and I guess I was talking about system of linear equation. But literally, what do we call linear equation? There are things that you are actually you've been used to right from your secondary school days. They tell us that there are some certain particular variables of numbers. Unlike just your simultaneous linear equation that they'll tell you you have x1, you have x, you have y, and much more like x, y, z. In this kind of linear equation, you have more than that, you get. So you can have a certain numbers of tuple. Now it says that linear equation are some certain numbers of variable. That's x1, x2 to certain partial numbers, Sn. You get, which can be expressed in what? In the form you having a1 x1 plus a2 x2 plus a3 x3 and what? To a certain numbers of what? The constant also and the variable, which is equals to what? A certain solution. B. Now it says that this a1, a2, a3 they are actually beside the what? The variables, they are called what? Constant, which we all know, we are used to that. And at times, if the certain numbers of variable, let's assume like I just said now, if the certain numbers of variable is just 2, that's you just having something like a1x plus a2y equals to b. That one is easy, That is why at times we don't use x1, x2, x3, x4 as x1 standing for x, x2 standing for y. If there are a lot of linear equation being given, we will not be able to use x, y, z and things like that. We will have to use x1, x2. But since it's still on 2, you can use your normal x and y. Still on 3, you use your x, y, and z. And if you feel like you can easily use x1 and x2, if you could recall from my previous video, I actually utilized x1 and x2 because I feel like it is much more, interesting. Or let me just say, it is actually cool. Now, from that particular point, now we have system of linear equation. Then, how can you now define system of linear equation? We can say that what is finite set of linear equation is called a linear system. Are you me? Or we say what? That means you having a certain numbers of what? Of sets of linear equation. In that moment, they are in a category where we should call them a system. You get? So in that point, that is what brought about what we call a system of linear equation. And these variables that we have been looking for, they are always called unknowns. You know them already. These are examples of a system of linear equation. You having more than this, exceedingly this one, or more than, you get. So this is called a system of linear equation. So let's talk about something we call solution. All right. So when we discuss what we call solution. Now we say that a solution of a linear system. That's if you're having like equation one, equation two, equation three, many more. If those are what we call the system, and the moment you are aiming for a particular solution to the linear system of some certain unknown, like x1, x2, so a certain numbers of x variable you have been actually the x denotes each category, like you saying x, y, z, and stuff like that. So it is a number of solution that will be substituted for the unknown, because we are having unknown, and for a certain unknown you need to get the solution or the answer to the unknown. Just like you saying an unknown variable s will be equal to a solution of x, also that's unknown variable 1 will be equal to a solution of 1, unknown variable 2 will also give us a solution of 2, unknown variable 3 will also give us a solution of what? Of 3. This is what we call a solution. So a solution of a linear system with a certain number of unknown that we are being given, it has to be specified. It's not infinitely unknown values. You have to be either it is 4, it is 5, it is 7, it is infinite numbers. So from there now, it says that what can be written as solution 1, solution 2, solution 3, then blah 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 to the stuff like that. Now it says that we usually call it like I told you, an ordered n tuple. So if the n is equal to 2, are you with me? That's if the system of linear equation they gave you is equal to 2. Just let's say equation 1, equation 2. In that point, the n tuple is what we call an ordered pair. And the moment the n equals to 3, that's the system of linear equation you have been given. The linear system is 3, equation 1, equation 2, equation 3. In that point, we call it an ordered what? Triple, and many more. So we have 3 sets of linear equation. The first one is when you have a no solution. The second one is when you have a single solution. And the third one is when you have an infinitely many solution. So let's check them out one by one, starting from the no solution. So at this particular certain point, under the graph engagement, this kind of equation, the lines are going to be parallel and they will be far apart, they will be distinct. You get what I'm saying? So in this case, we don't have any intersection, nothing intersecting themselves like this on any axis. So since there is no intersection, that means consequently it has no solution. So if you look at this kind of equation, we want to solve this kind of equation now. In this point, from this particular, if you are to apply elimination method to it, you have this as 3x plus 3y equals to 12, and this one times 1, you have 3x plus 3y equals to 6. So this is just like the augmented matrix aspect. So I want to try to actually explain something to you guys so that you know how to utilize or say it whenever you see it. Now if you apply elimination method to this, now we subtract now. So this becomes, the answer you are going to be having is 0 plus 0 equals to what? 6. So the moment the two variables tends to 0, that's in the point at which the coefficient of each axis tends to 0, we're having a constant solution. That's a constant value at the end. In this kind of process, you can't find any solution from this category. Why? Is that if x, there's nothing to sit for in x and what and y. Are you getting what I'm saying? And also again, the whole equation was not breaking down into a what? A linear system, a linear equation. Like we're saying from equation of line, y equals to mx plus c. That is not for this. Assuming this is also 0, that means one equation has been what? Has been eliminated, and you can be left with only a single equation. Are you getting what I'm saying? So for you to, whenever you see something like this in any matrix, augmented matrix, and they ask you what kind of solution is this, in that point you have what? A no solution. So I could write it like this: 1 4, then I have 0 0 6. So the moment the coefficient of the matrix are 0 and you have a constant value at the normal part there, in that process, that kind of matrix, we call it a no solution matrix. Are we clear? So that is the first part. Let's talk about the second aspect. So under a particular linear algebra, under that particular aspect of solution again, we say that the line may intersect at just one single point. So the moment the line intersects at a particular single point, in which the particular case we have exactly one solution. As you can see, this particular linear equation, they intersect at just one single point. So an example, if you are to express it in just a normal little simultaneous linear equation, we apply elimination method, right? Then you have a 2x plus 2y equals to 2. Then from here you have 2x plus y equals to 6. So when we subtract, you have this as y equals to, then from this aspect you should have y equals to minus 4. So at this particular point, since your y is equals to what? A negative 4, we substitute y into a particular expression. Let's assume equation 2. Then from there your x would be equals to what? Would be equals to 5. So at this point our x is equals to 5, while our y is equals to what? Minus 4. So at this point we call it a normal single solution. So if it is written in normal terms of, what do they call it, of your matrix, you have this. So literally you have your 5, your 4, but they are still breaking down to this certain particular part that we need to what? You are still going to what? Utilize, and they're just trying to put it in a way where you could understand. So whenever you have this particular equations like this, you have this to be ascertained to give you your certain expression. So from the aspect of that, when we look into some other ones, like let's move into the third aspect. So the aspect at which we have the line. Now the line may coincide in which there are infinitely a lot of points, again I'm saying of intersection. So the points on the common line, as you can see. Now this is like a two certain line, but they are too close. They meet each other at a lot of certain points. You get what I'm saying? So in that process, it yields a lot of solution. And let's express something like this now. So like I told you now, this is a single solution, and this one now gives me any solution. So if you are to apply, what do they call it? Our normal simultaneous linear equation to it, in order not to waste our time, we have this as 32 x minus 16y equals to 8. Then we have this as 32x minus 16y equals to 8. Are you with me? So in this point, when you subtract by using the elimination method, your answers gives you 0 plus 0 equals to 0. So the difference between a no solution and infinitely many solution is that infinitely many solution will break down a certain row into a non-existing part. That means that you'll be only left with what? Only a single equation. Are you with me? And from that single equation, you will recall back to what we call equation of line. That's a single linear equation. And from there, we are going to be left only a single equation equals to 1. So in this point, whenever you see this kind of point in a matrix, then I'm just trying to use the matrix to express some certain things. In a matrix, then that's in an augmented matrix, you have 0, 0, and 0. In this kind of expression whereby the quotient is 0 and the constant value is also 0, in this kind of point, the matrix we call it what? A many solution matrix. Are you with me? So in this point now, you know that we can actually make it looks like equation of linear, a single equation of line. And how? You have 4x equals to 1 plus 2y. Then from there you have x equals to 1 over 4 plus you have your what? Your 1 over 2y. Are you getting what I'm saying? So from there now, this y could be utilized as what we call a parametric equation form, whereby the parametric value t can take 0, it can take 1, it can take negative 1. So for every value we insert into y, it gives us another certain value of x. That is, let's assume if t is equals to 0, you have x being equals to 1 over 4 at t being equals to 0. Are you with me? And if t is equals to 0, that means y is automatically equals to 0. So at t equals to 1, you have x being equals to 3 over 4, and automatically at y equals to 1. So if t is equals to negative 1, you have x being equals to a negative 3 over 4 at y equals to negative 1. So all these has yield a certain lot of solution. It will give a series of solutions. So at this point, we say we are being bombarded with what? With infinitely many solutions. So that is what we call an infinitely many solution. So we have one last thing to explain to ourselves is that if you are being given a linear system, we can say that linear system is consistent. If that linear system is consistent, that means that the linear system either has, just like what we have here, either has one solution or infinitely many solutions. Whenever you have infinitely many solutions, that kind of linear system is consistent. And whenever you have a single solution, that kind of linear system is what? Is consistent. So the moment the linear system does not have any solution at all, whereby the graph are at parallel them and they are distant from yourself, in that point, the linear system is, we call it what? An inconsistent linear system. That means that what? The linear equation has no solution. And the moment it has no solution, you can't provide an answer to the certain particular equation. So at times, this solution helps us to quickly understand when you're being given a certain question that, okay, this question actually has no solution. So thank you for watching this. Please try to like and subscribe.